We're on problem number 22 of the 2009 January Regents Math A exam. And here we have a picture, and it says, which point is a solution for the system of inequalities shown on the accompanying graph? And here's the very nice graph they have drawn for us. And then down here are our choices. This kind of question is good in case you come up against maybe a free response question that has you graphing some inequalities, because it shows you, for instance, here we see y greater than or equal to 2x minus 1, right? Right here, y greater than or equal to 2x minus 1. We see that, and we see it's a solid line, and it's shaded to the left. It's actually shaded above where the y-intercept. And here we have, y, 3y less than, it's a dotted line, and it's shaded below the y-axis. This is great in case you forget some of these details. You can rework it from the problem. But here we only have to find which point is a solution. So we have to know what a solution means. And a solution means anything in the area that is shaded twice. It cannot be on this dotted line. It can be on this solid line. So anything in this region out here, anything at all in there is a solution. So we just start looking at these points and plotting them and see if they fall in that region. First one is -4, -1. So we go -1, 2, 3, 4, and we go down 1, and bam, there it is. That's the solution. That's the answer. It falls in that doubly shaded region, and we're done with the question. Let's go and just to show you that the other ones are not solutions. Okay, 2, 3, the point 2, 3. So I go over 1, 2, and up 1, 2, 3. That falls right square on that line, but it's not in a doubly shaded region. So that's not an answer. Number 3, choice 3, it says 1, 1. So the point 1, 1. Now this is tricky. 1, 1 is at the intersection of these two lines. But notice that 3y less than -x plus 4, that is a dotted line. That means that any point on the line is not a solution. Okay? And we can see that because we just take 3y, right? 3y must be less than -x plus 4. Well, if we take the point 1, 1 and put that in there, 3 times 1 is 3, and this has to be less than -1 plus 4, because I put 1 in for x, so -1 plus 4. So 3 is less than 0? No. No, that's not true. That's not true at all, and that's why this, number 3, is not a solution. And then the other point is -2, +2. So we go -2 and then up 2. And once again, we have a point that's on this line. And if we go through and substitute it in here again, we have 3 times -2. That's -6. And that should be less than -2 plus 4. So -6 is less than... should be -6 is less than 2. Oh, well, that is true, actually. So maybe the graph isn't quite accurate here. But the point is it does not satisfy... Did I do something wrong? -2, -6. And then... Oh, man, you know what I did wrong? And this is good that you see this sort of thing. I flip-flopped the x and the y here. Totally got that wrong. The y coordinate is +2, so it should be +6 is less than, and then when I put -2 in for x, I get 2 plus 4, and I get 6 is less than 6, and again, that is not true. So that does not work. Sorry for the confusion there. All right, moving on to the next problem. Number 23. Which statement is an example of a biconditional statement? Now here again, biconditional, oops, don't want to cover up the word, biconditional. That means two conditions. And basically you have to know the definition. A biconditional statement is if and only if. It has to have that key phrase, if and only if. So we read through the answers and check it out. This one has if and only if in it. All the other ones do not have if and only if. So This is your answer. Those are not. Okay, we're just looking for if and only if. That's the definition of a biconditional statement. Number 24 says, what property of real numbers is illustrated by the equation 52 plus quantity 27 plus 36 equals quantity 52 plus 27 plus 36? Okay, that is the associative property. We are associating these two numbers. They're kind of buddy-buddy in the parentheses. Then we're associating these two numbers. They're buddy-buddy in the parentheses. They're associating with one another. And you get the same thing, because if I have $52 and then I add to it the sum of $27 and $36, I have the same amount of money as if I had my $52 plus my $27 first, and then I added $36 to it. Again, that's just a definition. This is a definition problem. There's no real math going on here. You just have to know the definition. And number 25 says, how many different two-letter arrangements can be formed using the letters in the word brown? Okay, now this, if you don't know the trick to this problem, it can take a while, because you're going to go through and try and list all the different two-letter arrangements, and maybe halfway through figuring out you'll find the shortcut. But basically, brown has 1, 2, 3, 4, 5 letters. That means for your first choice of letters, first choice, right, of these two-letter arrangements, you have 5 total choices. Okay, so I can pick any one of these letters. I can pick B, I can pick R, I can pick O, I can pick W, I can pick N, but I have 5 choices for the first one. So I pick one. Now, after I pick one, say I pick the letter B, right, I only have 4 choices left. So for my second choice, I have only 4 letters left, 4 choices. Well, 5 times 4, I have 5 choices, and then after that I have 4 choices. That's 20 total arrangements. Okay, arrangements. 20 total arrangements. So 5 times 4 is 20, and that is the answer. And we'll do one more here. Oh, we don't have time for that one. We'll get it in the next video.